All right. Hey, everyone. I'm Alex Miller. I'm the CTO of Grid Plus. And today I'm going to be showing you what more readable transactions, Ethereum transactions, might look like, do look like today on hardware. So Grid Plus, oops. So Grid Plus manufactures a new hardware wallet. It just came onto the market in December. We sold out of our initial batch of them, and we're working very hard to get the factory back up to manufacture more of them. So I actually have one with me. I just wanted to show. Okay, I should take it off. Okay, yeah. So this is the Lattice. It's a larger hardware wallet than you might be used to. Once you get the box, this is what comes inside. It's a little device, pretty big screen. It's wireless. I mean, you have to plug it in for power, but it's wirelessly connected. You get a little safe card here, which is like an extensible wallet. So let me go back. Okay, let me just plug this guy in because I'm going to do a demo in a minute. Okay, so the Lattice One is our new hardware wallet offering, and the real message behind this device, the real impetus behind it, is that we designed it for crypto usability, specifically Ethereum, specifically DeFi in the year 2021. So there's a lot of features that come with this device, but I'll just kind of briefly touch on the most obvious ones. It has a large screen, so obviously with that you can display a lot more information than you would on some of the other hardware wallets. It's wirelessly connected, so there are actually features that we have and are continuing to build that allow you to set permissions like spending limits and stuff like that. So you potentially will be able to use this thing away from your computer. It has extensible cold storage. So in the foreground of that photo on the right, you can see our safe card packs. Now inside each of one of those packs is it's like a debit card looking thing. I just had. So it looks like this. It has this little chip, and that's where the wallet goes. So what this allows you to do is have offline backups. And there's all sorts of different backing up, restoring, splitting key mechanisms that we're developing. And then it has a bunch of physical security features as well. I mentioned it was wirelessly connected, so we're aware of attack vectors that may introduce, and we've designed with that in mind. So if you want more information on this, go to gridplus.io/lattice. It should give you a lot more information about the security features in particular. And then the last thing I want to cover just briefly is that we have lots of dev tooling. So we are trying to get more integrations with DeFi apps that our users want to use. So if you are interested in pursuing an integration, we have a Discord server. It's on our sites. So just hop in, and I can point you in the right direction for dev tooling. Okay, so as far as readable Ethereum transactions, let's set the stage by going back to 2017 and kind of looking at how user experience has changed over the years. So MetaMask was first launched in 2016, and I'm not totally sure what version the screenshot on the left is from, but it's one of the older versions. And as you can see, there's just a lot more information than you might be used to today. It's a clunker UX. It's a 2016 UX, right? And when you fast forward to the year 2021, those of us who have been using MetaMask for a number of years, the user experience is just so much better. There's so many more features. So the screenshot itself doesn't really do justice to the point, but it's improved pretty precipitously over the last 4 years. Similarly, when you look at dApps that are running on Ethereum, back in 2017 in the DEX space, you had EtherDelta, which was essentially trying to replicate the Coinbase Pro experience, but with 15-second to 30-second settlement times. So you'd be staring at this screen, and then like every 15 seconds it would like update because trades had been made. It was a terrible experience. So Uniswap invented the automated market maker, and today, DEXs in particular, but also dApps throughout the space have just gotten so much better from a user perspective. It's just when you look at these two UIs, it's just night and day. However, if you're talking about sort of the last mile, as I call it, of using Ethereum, I would kind of argue that your final endpoint, your hardware wallet, hasn't really changed all that much in the last 4 years. So on the left, there's the Ledger Nano S, which is the hardware wallet that I used for a number of years before the Lattice. And it was great for what it was designed for. It was designed, sort of in the early days of crypto for the purpose of really storing your Bitcoins offline, having some sort of peace of mind that your cryptocurrencies weren't being stored on like a hard drive because there were all of these stories about people getting hacked. So that was really, to me, the purpose of a hardware wallet back in the day. So if you fast forward to 2021, this particular ledger in particular has upgraded to the Ledger Nano X, which I understand has more storage, a few more features. As you can see on the screen, it certainly has more resolution, so it's able to display a bit more data. But sort of at the end of the day, you're looking at a USB-like, sort of like something that looks like a USB stick. It's going to be limited by the size. It's going to be limited by the chip that you could put in that device. So also in 2021, we have the Lattice. So right off the bat, personally, I would say this is it is a better experience just due to the fact that you can display so much more information on one screen. That said, it's not where we want to be, right? Because the real problem here, aside from just not having enough information on a small screen, is that even if you do have enough information, hex strings are not really designed for users to interpret, right? So you take your average DeFi user, right? If they're looking at the thing on the right, like, yeah, it's a lot of information, but honestly, what are they going to do with that? So we need to do better, and that is kind of the purpose of this talk. So the Lattice, one of the major thrusts of this product, especially in the Ethereum side, is that we want the experience of using Ethereum and signing transactions to be vastly improved, and we want it to kind of catch up to the UIs that we've seen evolve much faster on the website. So we have kind of three major focuses in this vein. So the first one we get for free, basically. It's the large screen. It's the first thing you notice with the device. Like I pointed out, you get to view a lot more information on one screen, which is great. The second thing, which I will be covering in this talk, is readable transactions. So we want to actually, take that hex data and display it in a way that is at least more intuitive for the average user. And then the third thing, which we haven't implemented yet, but is on the roadmap, is this concept of an address book, because we're still using, in 2021, we're still using hex addresses. Now, ENS has been around for a few years, and that is certainly gaining traction. But on the hardware side, it's difficult to incorporate that for a few reasons. So at some point, we'd like to get an address book in, and maybe that would use ENS, but we're just not quite there yet. Okay, but readable transactions, we do have something for you here. Before understanding how the Lattice makes transactions more readable, I just want to cover what makes that possible, which is the Ethereum ABI protocol. So the ABI stands for Application Binary Interface, and Ethereum's ABI protocol is specifically a protocol for serializing parameters that go into, for example, a smart contract call. And it's a protocol for serializing, all these different parameters into one string, one byte array that can be sent to an Ethereum contract and parsed. Now, of course, if you have a protocol to serialize, you can also use that to deserialize, which is what we do with the Lattice. So static parameters, as I call them, so like your integers, your booleans, stuff like that, these are all encoded. These are pretty easy to parse. These are encoded as 32-byte buffers because they are fixed size. Dynamic parameters, strings and byte arrays, they're going to have more specific rules as far as how they're serialized depending on where they are in the ABI definition. And if you want to learn more about how this works, there's good documentation with the Solidity docs that's in that link at the bottom there. So once you have your parameters serialized, you're going to prefix them with a 4-byte function selector. And that function selector is basically just the first 4 bytes of the KCAC 256 hash of the quote unquote canonical definition of the function that you're calling. I'll do a very simple example here just to hammer this home. ERC20 transfer function, very simple function. Anyone who's ever looked at or worked with Solidity in any way should be able to understand what that first line is saying. It's just declaring the function. It's called transfer. Takes 2 parameters, the receiving address and the number of tokens. So to transform that into a canonical representation for ABI purposes, you strip out the decorators, and in this example, that would be the word function. And you also take out spaces and parameter names. And then finally, if you have any non-canonical types, so for example, uint, they need to be swapped with a canonical representation. These are just, you can use them interchangeably in Solidity, but for the purposes of ABI serialization, you need to use the one canonical type. So once you have that definition, that's your canonical definition, you do the hash of it, and you take those first 4 bytes, and that is your function selector. So every ERC20 transfer function that you would ever pull up on Etherscan, if you go to the transaction data field, the first 4 bytes of that data are going to be that function selector right there. So I went and pulled a random ERC20 transfer transaction. And if you go on Etherscan, there's 3 different views. One of them is not useful here. The 2 views relevant here are at the top, you have your raw hex string. So this is the serialized call data payload with the function selector in front. And then you have 64 bytes, 32 per parameter. And that first 32 bytes is going to have the address. The second 32 bytes is going to have value. Now, Etherscan, I don't know when they did this. It was maybe 2 years ago, something like that. They brought out this parsed view, which is the default, which is that bottom one. And this is using the ABI definition, and it's stripping out that function selector at the front, and then it's slicing out those parameters. So the user's still looking at hex here, so it's not where we want to be, but it's certainly a step in the right direction because it at least shows you what the different parameters are that you're calling. So this is actually the inspiration for the feature that we have built into the Lattice. So unfortunate incident here that kind of bumped the priority level of this feature. There was an attack on a co-founder of a startup in the space who had a lot of Nexus Mutual tokens. The attacker was able to gain control of this person's laptop and swap out the MetaMask instance so that whenever he went to interact with the contract, like for example, calling harvest on some yield farm, it would take that transaction, it would just replace it with this nefarious one, and it would send that to his hardware wallet, which he was using. So he actually was using a hardware wallet for this transaction. And what came across was that input data at the bottom there. And for whatever reason, he either just assumed that it was fine or was unable to read that. And regardless of what the reason was, It just wasn't a very good UX. It wasn't a UX that afforded him sort of the skepticism of a nefarious transaction. So he signed it, and unfortunately, just lost a ton of money. So yeah, I mean, we saw this happen, and we had already had this feature in development, and we were like, we need to move a little faster on this. Okay, so how does the Lattice protect against this? So we have the ability to use ABI to decode this raw hex blob, and I'll show you what that looks like in a sec. But just the mechanics of how this works. So a user would first identify a smart contract that they want to be using in the future. For example, the Uniswap v2 router would be a common example. And the first step is that they would load ABI definitions. And I'll show you in a demo real quick how that works. But basically, they initiate this request. The device asks and validates that they initiated that request. And then once they say that they did, it's going to start negotiating with the interface that is loading these definitions. So once they've all been loaded, they are not yet committed to the device. They have to be approved. And on the right here, it may be hard to see, but it's showing you a set of canonical representations of these ABI definitions that you're loading in. And this example is the Uniswap v2 router. So once you approve these, it's going to commit these to secure storage, which means that we have this level of confidence because the user, first of all, told the firmware that they initiated the request, and second of all, they told it that the data that they're loading into secure storage is valid. So we have some level of assurance that this is a proper ABI definition. And at that point, any transaction that comes through is going to be able to access that definition and use it to mark down the hex. So this is actually the same transaction in a different view. Again, this may be difficult to see. Apologies if it is, but it's showing you the name of the function, in this case, swap exact ETH for tokens. So immediately that gives me a sense of what's going on here. And then it's going to deconstruct all the parameters and give you the values associated with those parameters. It's also going to obviously give you the human readable names of those parameters. So just as a quick example, just to point out, that first parameter there is going to be the amount out min, which is the number of tokens that you're receiving. And you probably can't see that, but it's like 1.08 times 10 to the sixth. In this example, this is $1.08 worth of USDC being received. USDC, I didn't know this, has 6 decimal places for some reason. So that's what that E6 is. Unfortunately, because we don't have context as to like what this transaction is doing at a firmware level, we have to use atomic units, as I call them. So for example, with Ether, that would be way rather than the ETH unit. But it's still in base 10, which we think is a pretty big improvement, at least, over displaying this in hex. So the process of what's happening here for those interested, when you have ABI definitions loaded into secure storage and you have a transaction come in, the firmware, and it's an Ethereum transaction, we should specify, the firmware is going to, first of all, make sure that there's contract data, there's call data in the transaction. So you need to have a minimum of 4 bytes for that function selector. And once it confirms that it's not just a simple ETH transfer, it's going to fetch the ABI definitions from secure storage. And it's going to search for an ABI definition from that set. It's going to search for a match using the first 4 bytes of the call data from the transaction coming in. So if it finds a match, it's going to go through a series of checks, and it's going to attempt to deserialize that data. Now we're pretty strict on the firmware side. So if it fails any one of these checks, it's just going to sort of abort the process, and it's just going to show you the raw hex. So in a sense, that in itself is a sanity check for the user. So if I know that I've loaded up Uniswap ABI schema, and I go on Uniswap and make a transaction, and it shows me hex, that might be an indication that something has gone awry, and that might give me pause as a user. So that's really what we're trying to afford here. We're trying to give the users at least some leverage over an attacker who could just swap data that they otherwise wouldn't be able to read. We want to give them the ability to at least have some sort of defense mechanism against that. So just one more point. Like I said, we're pretty strict. So if we find a match, we have to deserialize every single parameter. All of the types have to match, the order has to match, and we can't have any leftover data in the call data, and we can't overrun the call data either. So there's quite a few sanity checks that go into this. So assuming we have found a match and we were able to deserialize, we're going to loop through all of the deserialized decoded parameters, and we're going to display each one individually. So what we're doing here is we're just building a display. And if the user approves off of that display, we just hash and sign the original payload. So we're not mutating any payload here. This is just purely a display feature. And yeah, again, if any check fails, we display the original payload in X. Okay, so I'm going to do a demo here. See what the lattice is like. Okay. Okay, so I have my lattice here. Sorry, the screen is reversed. So I'm just going to pin in. Okay, so yeah, a lot of text on the screen, but if you go to your smart contracts tab, I don't have anything saved in there. And I am going to, it's going to take some coordination, so apologies if this is a little clunky. I'm going to go to Uniswap. And I'm going to try to, well, first of all, I have to connect. So we have a fork of MetaMask that we maintain that gives you Lattice access. So technically anything that you're using that uses MetaMask should work on the Lattice. Okay, so I'm going to swap 0.1 Ether for some Aave. I'm actually going to stop sharing here.
Just let me know, Alex, and I'll go back and forth for you.
Oh, you will? Okay.
Yes, I can. Once you start sharing, I can bring it up and take it down if you just let me know.
Okay, I will do that.
Great.
Go back to Uniswap then. Okay. So I also have to have this viewable. Okay. So I'm going to initiate this transaction. Uh-oh. Reload. Should pop up in a second here. So here's the hex blob. As you can see, yeah, there's actually 2 screens worth. So you are able to page through if you want to look at additional data. But yeah, this is not super useful to me. If I didn't have very much money on here, which I don't actually, I would probably just approve it. But if I have a lot, then I would very much prefer to look at the ABI view. So exit out of that. I actually need to go. Sorry. Now I need to go to the Grid Plus web wallet, which I should have had pulled up. Sorry. Okay. So the Grid Plus web wallet is a very, very simple wallet tool, but it's really more used for management of the device and for things like this. So if I want to add the Uniswap router functions, I would go to the web wallet, I'd search for that address. This is the router v2 address. And it's going to search for Etherscan and find the number of ABI functions that are state updating functions. So we don't care about things like view balance. This is really only relevant for things that you would be using when making a transaction. So while there are more than 20 functions in this contract, there are only 20 functions we would actually interact with. Okay, so I'm going to send those to Lattice. It's going to pop this up, this screen again. It's going to say, you're trying to add 20 functions. Yes, I did initiate that. So it's now negotiating with my browser. It loads two at once because the data that goes into them are fairly large. We do have a kind of constrained request size here. So it's just going to take a minute. And once it's done, it's going to start showing me those definitions. Okay, so bring this up. So as you can see, like I was talking about, the tightly packed definitions, there's no parameter names, just the types. So I'm going to go ahead and approve these. Approve. It's going to bring up another set. I can actually only do 18 at a time. This is so hard. Okay, so it says that they're added. This is good. So if I were to go back to this smart contract screen, it would now say instead of 0, I have 20. All right, so now I'm going to go back to Uniswap. I'm going to do the exact same transaction. Okay. I'm actually going to stop sharing just so I can show you this with screen. Right on MetaMask. Okay, so now when it pops up, it should look very different. So yeah, loading those contract definitions allowed me to start getting more parsed views for when I use Uniswap and its functions. So again, you can scroll through. There's a few more parameters, and those just kind of give you human readable names and uint or base 10 numbers. Okay. Back to my deck. Okay, so yeah, I mean, I'm quickly running out of time here. So I'll just say that this is not exactly where we want it to be. There's much better user experiences that can go into this that would not be terribly large lifts. So obviously having to find the Uniswap v2 router specifically as a singular contract is not the greatest user experience. So we really prefer to have some sort of searchable registry or like even a DeFi pack that would just load a bunch of DeFi functions out of the gate. The other thing is we can actually preload functions. So the ERC20 functions are already preloaded in here. So you will never, if you have a Lattice, you will never have to look at hex for an ERC20 transfer. Better definition management in the Lattice. I didn't cover this. I'm just going to skip it for now, but basically there's not a lot of resolution in what you can delete if you want to delete stuff. And then Sourceify is a great project, a great open source project with collaborators from the EF that is working on a similar problem to this, working to get a better sort of data source for these ABI definitions that would have validation built into the metadata, which would potentially allow us to load these in real time. I don't want to commit to that. Need to look more into it, but that would potentially be a future direction. Okay, so just real quick, a little plug here, Grid Plus, we're hiring. We are a very small team, we need help. So if you are a software engineer who wants to work in the crypto space, give us a shout. See what you would be doing specifically is, I talked about the integrations with third-party applications. You'd probably be maintaining some set of dev tools and also maintaining some integrations. The web wallet, we're adding features to that as we add features to firmware, so that would need to be maintained as well. We have stuff going on in the cloud as far as message routing, which we also want to allow users to kind of self-define. So I'll have a blog post coming out on that shortly. And then additionally, Lattice software, there's stuff that runs on the Linux chip inside of this Lattice specifically that you would be working on. And yeah, like I said, we're a small team, so you'd be doing a ton of stuff. So if you're interested, careers at GridPlus. And that concludes readable Ethereum transactions. So I guess I have 1 minute. If there's any questions, let me know. Otherwise, feel free to reach out on Twitter. Thanks for having me, and thanks for watching.
I don't see any questions. There's some good comments though, if you want to check them out.
Yeah, just put up one comment or question.
Yeah, we'll be able to use Wallet Link or Wallet Connect. We just flashed it on the screen, Alex. You can read it right there.
Yeah, I see it. Probably not. We'd explored this before, but I think generally speaking, we don't want to be in the business of being a wallet provider. So honestly, I'd have to look more into it. I can't remember where we landed on that. But right now, we're pretty content with direct integrations in our MetaMask work. EIP 712, I want to get to this real quick. We really want to add EIP 712. There's some technical blockers at the moment. Once we're doing a firmware update, which is going to take some time, but once that's in, I actually have the code for EIP 712 in. It doesn't fit, and it requires some dependencies we don't have. So we are working on that. What else? Let's see. Native ENS, I really don't have time to get into why that's difficult for us, but basically, generally speaking, we want users to pre-commit data to secure storage. We don't want to just be pulling data from the internet and using that on a secure screen to display transaction data. So that is the real problem with ENS. That's not to say there aren't solutions around it, but that's kind of the blocker at the moment.